Here? Okay, excellent. Thank you again, and thank you for the IIPLA for inviting me to this conference. And the topic this morning, and also for the rest of the day and tomorrow, I think would be very interesting and instructive for everyone, not just for IP counsel, but also for all the practitioner and business people. And yeah, just like I was introduced. I used to practice in Europe and also in the US, and on both sides, in-house and in private practice. And I had the chance in some way to see the business running the IP, and also how the law firm are trying to help the business acquiring the IP and to enforce them. And so before joining GE, I worked for different companies, starting with IBM. So it was in the telecom and in the semiconductors industry. And after that, I switched to Nokia. Also, that's why I was happy to see one of my maybe a coworker, Leo, and after that, I joined General Electric. And as you can see on this screen, it's about electricity and not semiconductors or telecommunication. And so GE actually acquired Alstom, as you certainly have heard about last year. And Alstom was one of the main European player in the energy activity, and it was a kind of competitors to ABB and Siemens. And so GE has joined force with Alstom to create that kind of electricity value network. And the electricity value network is very important for the future, not just for the business, but also for the consumer. And so here I can show you actually the industry in transition. And you can see that there are a lot of things at stake. Okay, so you can see that there are 5 billion of, let me get closer to the 5 billion of internet user, and at the same time you can see also that there will be 3 trillion of IP devices, and you have certainly heard about the IoT, right? The Internet of Things, and this is going to be a huge market that we have to tap in. So it would be in 2013, and it's not too far from now. It's just about 13 years ahead down the road. And you can see that we heard about the Uber, and of course the Tesla car, and the electrical car, and the autonomous car. And we are not just looking at the autonomous car, but we also look at the autonomous vessel, meaning that those big ships that can navigate around the world can be autonomous without having any crew on board. So in that way, they can completely navigate around the world, transporting not just goods, but also maybe some important merchandise. And also by 2050, we would have to reduce by 50% of the CO2. So it's very important, like you know, the COP in Paris, that was the agreement, even though Trump has decided to not go into that direction. But nonetheless, you have a different state in the US that are quite interesting in this agreement going forward. And, and once again, the digital transformation of any company, not just GE, would increase a lot of opportunity. And you can see that it's not just about the turbine, but it can be also the cars, as mentioned to you, and it can be also for the vessel. And you can say that in this chain of energy, it's not from the generation to the market operational trading, the transmission of the energy, as well as the distribution. And it can go into the residential as well to the commercial units or commercial industrial. And the APM, that what we call also the asset performance management, will help optimize and help also manage the different maintenance. And the grid optimization aggregation is also one of the aspects that we have to consider, and that's where we also find a lot of innovation, because the grid is very important for dispatching and for also democratizing the electricity. And you have also the services that can come in to play in order to make sure that the customer can be satisfied and use the electricity in a value added chain of energy. And you can see that if we look at the uh, the the value of those change of energy, you can expect that 1.3 trillion can come from the service platform and the smart devices and the cloud. This morning, I think that the gentleman from Microsoft was talking about the cloud. So the cloud is an important part of this industrialization or digitalization, and it's going to be maybe one of the way to share all the data and the big data, especially when you heard about this phenomenon. And so you can see that it will bring a lot of benefit to the society in terms of reduction of the carbon and the environment, as well as the creation for consumer. And so the top trend of the digital industry would be the impact of renewables. As you can know, the renewables can come from not just the solar, but it can come from the wind industry as well as the hydro. And this would bring about also the use of artificial intelligence that would also in some way manage and help this energy being transported from one point to another point. And you will see also the multi-directional in the new grid. So the grid would be also not just for the electricity, but it can, in the electricity transformers, but it can also be close to your house, because each consumer now can produce more or less the energy. That's what we call the prosumer. And so this bring about a new source of revenue. And of course, those innovation have to be protected by patent. And so patent is an IP in general will play an important role, not just for the hardware, but the software. And so the commitment of GE is to create what we call the mind and machines. And you can see that GE is investing about $1 billion per year in this new technology. And at the same time, it has generated about 30% of world generation capacity. And so we have around 20,000 developers for the Predix. That is the platform for the digital ecosystem. And of course, we have filed something like 5,000 electricity sector. And that's a big numbers. And so this show is actually was in Paris. Maybe you cannot see it from this picture, but we are hosting this show throughout the world. So there is one in Berlin currently, and there is one also in Shanghai and also in San Remo in California. And so here is more or less maybe the description of what the digitalization would yield benefit across the energy network. And you can see here that it's not just about the gas turbine using the fossil energy, but also the nuclear, the renewables energy, as I mentioned to you, in the solar as well as in the wind, and the transmission and distribution, as I said to you earlier. And for each technology, there is a business that is taking care in order to make sure that the patents are filed, and to make sure that, of course, those patents are valuable for the company. And so here is the different layer, if I can describe in that way. So you have those chain of energy just down there. You have the steam, the gas, the nuclear, and the hydro, solar, and wind. And on top of that, you have the platform, the Predix platform. It's just like the operating system, if you can put it that way. Like in the telecom, you have different layers, right? So the Predix is one of the operating system of those assets or those hardware. And on top of that, of course, you have the cybersecurity that is going to be working operating next to it. And so you have the APM, as I mentioned earlier, and the operation optimization, as well as the business optimization. And so to make it a little bit more complicated, here you can have different meaning of what the APM can be, and it can be translated into different business model, like for the generation, for the trading, for the grid, and for the commercial and industrial energy. So we try to have as much granularity of the technology to make sure that we are not going to lose any sight of what we can protect in terms of IP. And after that, the value chain of the IP will be integrated in each business. And the Predix, as I said to you, is one of the important platforms that we are using. Just like in the telecom, you heard certainly about the Android, right? It's one of the platform, as well as the OS for Apple, and Microsoft was coming into play as a third platform. And here, GE is unique in itself because it's the first industrial internet platform that you can use in order to interact with different assets. Okay. As I said earlier, we have about 20,000 developers, and they are all working not just in France, but also in San Ramon and in Shanghai, and also in India. And hopefully this platform will be shared among different companies. And there are currently about 400 partners that are using this platform. And here are some examples of companies that are using the platform. And so this is maybe a video that I can show you.
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39. The number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing in my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the OpFlex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating.
Thank you. So this is just to give you an example of how actually the predicts and especially the APM can help you to manage the assets. And this is for the gas turbine or the steam turbine. So it can be actually generalized to the jet engine also. So the aviation, GE Aviation especially, is working very hard, to optimize the use of these kind of assets. And so currently in Paris, you have the Bourget, that is the Paris Air Show, and so you have GE Aviation working closely with SNECMA or Safran, and competing with UTC, and they are trying to gain as much market as they can in terms of selling those jet engine. And the jet engine is certainly maybe one of the forefront technology that they try to use these APM to optimize, especially for instance when you are flying from let's say Brussels to Tokyo, to find the best optimal flight ways, and at the same time to make sure that the asset is not going to break down. And if there is a breakdown, then they try to anticipate also the cost and so on. So this the simulation that you saw previously can apply also for jet engine. And so here is more or less, a simulation of what would be possible to obtain in terms of saving. So you can have here what you can save using the predicts, whereas if you didn't have the predicts, then the cost would be a lot higher. And at the same time, you can see that there is a wide range of different technology and different industry coming from, let's say, the solar, the wind, and the different hydro and so on. And so you heard certainly maybe during the video that they try to find how to optimize not just the operation and the hardware, let's put it this way, but also the finance situation in order to make sure that everything is being optimized with different data. So the big data is also come into play. And what we heard this morning about how to protect the software is completely fully applicable here, because it's not just about the hardware, the assets that you can manage, but it's also about how to put those assets in a certain way to optimize the use of them and the maintenance. And just like about maybe 40 years ago, when I was working for IBM, IBM was looking at the hardware, and they had to shift into a service company and to a software company simply because Microsoft was making a lot of money on the software. So now we have almost like the same situation in which you have the hardware that is the assets company like GE that is trying to put additional, let's say, intelligence on the product itself and create another layer of software. So that's why Microsoft is also a good ally to GE, and they are working closely together to maybe be the architect of the cloud. And so the cybersecurity is also a concern, because those data can be accessed, can be hacked, and so it's very important to make sure that the violation of those data can be tracked or sanctioned. And for the workers, they have to be also very, very skilled. And the skill that are needed into the digital world is completely different from what it used to be in the hardware. So I think that's where I can stop now. And so we can take question at the end, and that's it.